Hi, thanks for joining. I'm Priya Rajagopal, Principal Product Manager at Couchbase. And in today's session, I'll be giving you an overview of the Couchbase platform for mobile and the edge. I'll begin the discussion with the challenges of cloud-centric architectures and the role that a data platform such as Couchbase plays in order to address those challenges. I'll talk about distributed cloud architectures and how Couchbase aligns with those architectures. And I'll finally discuss some customer success stories on how Couchbase is enabling such solutions. A little bit about Couchbase, who we are. We build NoSQL database platform for cloud and the edge. We were founded in 2011, headquartered in Santa Clara here in the US. We've got offices all over the world. Our solution is built on an open source foundation. It combines the power and flexibility of NoSQL with the familiarity of SQL as a query language. And we count hundreds of household names as customers. Now, over the last decade, enterprises have been shifting their technology infrastructures from on-prem to the cloud. Now, cloud brings with it the economies of scale, the efficiency of infrastructure management, and the elastic scalability that allows it to scale with demand. At the end of the day, this results in lower TCO and a more nimble business model. So here's a typical cloud-centric architecture. You've got clients, they are consuming and pushing data to a centralized cloud data center. Now, in an ideal world where there's abundance of bandwidth and you've got 100% reliable connection, all clients are up and they're running and serving their users. But we don't live in an ideal world. So any network disruption means the clients are down and they are unable to service their users. So this effectively results in business downtime. Now, while the cloud-centric architecture, it offers the economical option for enterprises, its reliance on internet connectivity introduces a point of failure, over which there's very little control. Now, in addition to the downtime, since processing happens at remotely located centralized servers, there's a round-trip time latency that's incurred for the client data to reach the cloud, for the processing to happen, and for the results to come back. That latency is not acceptable for real-time applications. Now, although network speeds are on the rise, there's the promise of 5G. At the end of the day, you can't defy the laws of physics. Data transfer is governed by the speed of light. So there is going to be network latency that you really can't control. So in contrast, let's look at this distributed cloud architecture paradigm. In such architectures, the data storage and compute is distributed. It's brought closer to the applications that are the source of data and are consuming the data. Now, in this figure, they are represented by the red boxes. So the data processing could happen locally within the clients if the clients have the resources to support the storage and processing locally. Now, examples of such edge data devices could be smartphones, tablets, laptops, etc. Alternatively, they could be hosted or aggregated and processed in an edge data center. Now, examples of edge data centers could be an IoT gateway, they could be a server in an IT closet in a factory. Now, these edge data centers, they are co-located with the clients. They are typically on the same local area network as the clients that they serve. And functionally, these edge data centers are very similar or equivalent to cloud data centers, except that they are much smaller footprint because you're serving a smaller population of downstream clients. Now, when network connectivity is up, as in the cloud-centric model, all clients continue to operate. Of course, there are major or significant differences from the cloud-centric architecture. Here, the volume of data that's traversing the internet pipe is significantly reduced because you're doing a lot of the processing locally. The load on the server is also substantially reduced. And of course, the network latency that we spoke of no longer exists because you're not really relying on the internet bandwidth or the internet connectivity. Local area networks are inherently more reliable. And of course, if the processing happens locally on the embedded device, you're guaranteeing 100% reliability, availability, and responsiveness. Now, if the internet connectivity is down, clients can continue to operate because they are either served by the local database that's embedded within the clients, or they are served from the local data center. Now, if there is an outage on the local area network, and if the connectivity to the local edge data center is down, then clients with the embedded database will continue to operate. Of course, legacy clients or lightweight clients that don't have local storage processing, they will be offline. So essentially, we're talking about this new paradigm of computing called edge computing. Here, data storage and processing is brought closer to the applications that generate the data or consume it. Now, this sort of decentralized or distributed computing paradigm, it's gaining a lot of traction. And this is because of an emergence of a new wave of applications in the IoT, AI, ML, video processing space. So what are the typical characteristics of such edge computing applications? So what are the applications that benefit from this sort of distributed cloud architecture? First, applications that have to be resilient to network disruptions, whose functionality is not impacted by network conditions. So it's clear from the edge architecture slide that we talked about that you can maximize business uptime with guaranteed high availability. Applications that must guarantee real-time responses or near real-time responses. These are mission-critical applications that are literally dealing with life or death situations. You know, if you're talking about a vehicular collision system, for example. And then data privacy. That's a critical consideration for consumer applications in the finance or the healthcare space. So these applications are dealing with sensitive data. So privacy, data governance policies, they may prohibit data from actually leaving the edge devices or the edge data centers and to be processed in the cloud. And finally, these are typically applications that generate a lot of data. So these are data intensive applications. So applications, again, in the IoT space or ML AI apps. So transferring all that data, potentially ephemeral data, to the cloud for processing is going to impose a lot of overhead, not only to the backend data servers, but also to the network bandwidth usage. So by locally processing the data, you get the bandwidth savings. So as you can see, a data platform has an integral role to play in this edge compute architecture, because really at the end of the day, it's all about where the data is stored and processed. So when it comes down to it, there are two main elements of the solution: the ability to locally store and process the data, and the ability to sync the data with cloud data centers when there is internet connectivity. Now, although I talk about distributed architectures and the paradigm of distributing compute over to the edge, at the end of the day, the cloud is still the global aggregation point. It is the place where data is persisted long term. The edge essentially has to be in sync with the cloud. So a quick overview of the Couchbase platform. So it's composed of three components. You've got Couchbase Server, which is our standalone, scalable, performant database platform. Then you've got Couchbase Lite, which is our embedded, full-featured, again, NoSQL JSON document database. It supports all the functionality that you would expect from a full-featured database. Now, in contrast, with Couchbase Server, which is our standalone data platform, Couchbase Lite is embedded within applications. So these applications could be a mobile app, a laptop, desktop, or it could be an embedded application running on custom hardware. Now, to get the data that is in Couchbase Lite clients to the server and vice versa, you've got the sync gateway. Now, the sync gateway is sort of the middle tier component and is responsible for secure data sync and routing between the Couchbase Lite clients and Couchbase Server. It's typically co-located with Couchbase Server and handles authorization, access control, authentication, etc. And of course, you've got end-to-end security. Data is secure at rest and in transit. A key characteristic of our Couchbase platform is that you can deploy it anywhere. You can deploy it on a private or public cloud. You can deploy it on-prem. We also have a fully managed offering for cloud deployments. Another key attribute is that it's cloud native, so which means you can deploy, provision, orchestrate, and manage your Couchbase containers using Kubernetes. We've got an autonomous operator, which vastly automates this entire process. So I'd like to take some time to highlight some of the key capabilities of the Couchbase platform. So beginning with Couchbase Server. At the core of the Couchbase Server is our NoSQL JSON document store. Now, a key aspect of a data platform is data access. So for that, we support a comprehensive query API. We call that NQL, which is an implementation of the SQL++ standard. So you can essentially query structured as well as unstructured data with a very familiar SQL language. Got full text search integrated into the platform. You've got an analytics service that's built in for big data insights. The solution is scalable, it's performant, it's a memory-first architecture. So you've got a built-in cache layer, which enables you to service requests right there from the cache instead of hitting the disk. And once again, being cloud native, you can containerize it, which means you can orchestrate the deployment, provisioning using management options such as Kubernetes. Now let's take a look at Couchbase Lite. Now Couchbase Lite, once again, it's our full-featured embedded database. It's a NoSQL JSON store for mobile and non-mobile embedded applications. Again, being a database, you need a comprehensive query API. So we've got an API which has got SQL-like semantics, so ramp-up time is very, very low. We've got integrated full-text search, and we also have the ability for you to bring in pre-trained machine learning models within your application and use that for making predictions against the data that's stored in Couchbase Lite. There's built-in support for offline first mode, which is essentially the ability for an applications to function regardless of the state of network connectivity. So your applications can be used in completely offline mode, or you can sync data with the backend data stores when there is network connectivity. On-device encryption, so data is secured and encrypted while it is persisted locally on the client. And then, of course, you've got TLS for encryption of data when in transit. Now, as an application developer, you want to build apps that are reactive. You don't want to keep polling for changes that are happening in the underlying data store. So we have a comprehensive eventing mechanism that notifies applications when there are any changes to the underlying database, the documents, the state of the replication, etc. So we talked about where the data is locally stored and processed on Couchbase Server or in Couchbase Lite. But again, at the end of the day, we want the data to be synced between the edge and the cloud. So that's where Sync Gateway fits in. It's responsible for secure data sync and routing. And so here are some of the key attributes of a comprehensive sync technology that's supported by Sync Gateway. The sync, it can be unidirectional or it can be bidirectional. You can choose if the changes are synced in real time, which is our continuous mode, or if it is on demand. So essentially, apps are in control over when the data is synced. Apps are also in control over what data is synced. So we've got fine-grained filtering, which allows you to choose what subset of documents need to be filtered from sync. So for example, we don't want to push a document until the status field of the document indicates that it's in a committed state. Another key characteristic of a distributed system is that there are going to be data conflicts. So when you have a system where you have multiple writers who are potentially updating the content concurrently, you're going to have conflicts. You have to pick a winning version of the document. The system automatically resolves conflicts. And if that automatic conflict resolver policy doesn't work for you, you can define your own custom conflict resolvers. By default, sync happens at the granularity of your document, but with Delta Sync, you can just sync parts of the document that are changed. This is very critical when you're talking about syncing potentially large volumes of data, but only a few attributes of that document have changed. And finally, fine-grained access control. That is defined by the user, so it allows the users to specify who has read or write access to the data. Now, that was a very quick overview of the Couchbase stack. Now, with that context, let's look at how Couchbase aligns with the distributed cloud architecture. So if you think about the distributed cloud architecture, you can normalize that into three models. In the first model, the data processing happens at the device or the client side. Now, examples of this model would be field applications where you've got clients out in oil rigs, construction sites, etc., where there's poor or no network connectivity, but clients still need access to the data. So this is how Couchbase aligns. On the cloud tier, you've got Couchbase Server and Sync Gateway. And on the client tier, you've got Couchbase Lite, which is embedded within your client applications. Now, in the second model, you've got an intermediate tier between your cloud and the client tier, and it's the micro data center. This is where all the data processing is handled on behalf of the downstream clients. Now, examples of such deployments, it could be stores, hospitals, smart cities, etc. So in this case, clients are lightweight or thin clients. They don't do any local data storage or processing. Example could be a barcode scanner, legacy point of sale terminal, etc. So again, how does Couchbase align? On the cloud tier, you've got Couchbase Server, Sync Gateway, as was the case in the previous model. On the client tier, because these are thin clients, they are not capable of any data storage or processing. They could be lightweight sensors, for instance, right? So there's no Couchbase here. Now, when it comes to the intermediate tier, you've got two options. You can deploy Couchbase Server and Sync Gateway in your edge data center. As I mentioned, the Couchbase platform, you've got the flexibility in terms of where it's deployed. It can be on cloud, on-prem, in a public cloud, etc. So you will deploy a small form factor Couchbase Server Sync Gateway on your local hub and have it sync to the remote cloud service. Now, alternatively, you can deploy Couchbase Lite running within the context of a web services application. So of course, the scale of the clients that it supports is going to be very, very small in contrast to Couchbase Server. But Couchbase Lite would be, in this case, deployed within a web services application that would expose a RESTful interface that the other clients would talk to. Finally, let's look at the hybrid model. Over here, the data processing happens at the client tier, or it happens at the intermediate tier. Now, in this case, the clients could actually be switching between the intermediate tier or a cloud tier. So for instance, consider the case of a cruise ship. You've got users when they are before their voyage, they could be connecting to the cloud data centers from their mobile application. But then when they are on board the ship and when the ship has no satellite connectivity back to their cloud data centers, they would be connecting to the data centers that's on board the cruise ship. So how does this model align? As in the previous case, in the cloud tier, you've got Couchbase Server and Sync Gateway. In the client tier, you've got Couchbase Lite, and you can have Couchbase Lite directly sync with the cloud tier. Or you can deploy the edge data center with Couchbase Server and Sync Gateway and have Couchbase Lite clients talk to the edge data center. You can switch between the edge or the cloud data center. So now let's quickly look at some customer success stories. So Couchbase is deployed across all verticals: healthcare, retail, finance, hospitality, etc. And so I'm going to just touch upon a few examples to sort of drive home the benefits of such offline first edge computing capabilities. First, Becton Dickinson, or BD, is a leading medical technology company. It's based here in the US. Their goal is to improve the efficiency of healthcare delivery. So one of the innovations is the tools and technologies that they have developed for diabetes management. So they've got a mobile application that helps patients with diabetes track their insulin usage so they know if they've taken their insulin medication. They can also track their blood glucose levels in real time. So in order to do this, their mobile application, it connects to these blood glucose or BG meters and insulin devices over a Bluetooth LE connection. And it collects these readings and recordings in real time. This is analyzed, it's processed, and they can give patients custom alerts, recommendations, etc. It's very critical that this application can be used in completely offline mode. So where does Couchbase fit in? The mobile application is running Couchbase Lite. So the readings that are collected by the application over Bluetooth LE from these BG meters are locally stored in Couchbase Lite and analyzed and processed in real time to give the recommendations. And then, of course, when there is network connectivity, these recordings and stats are synchronized over to the cloud data center, which has Couchbase Server and Sync Gateway, and it is accessible to the patient's doctors via clinical portal. Switching gears to the retail sector, we've got Louis Vuitton, which is a luxury brand out of Europe, a retail network of 400 plus stores. And their goal was to enhance the luxury retail experience by putting the complete store catalog in the hands of the store employees, regardless of network connectivity. So essentially, the store level catalog and pricing information is pulled down to the store servers, and it's available to the employees who are running the applications on their devices. So which means even if there's a network outage, they can continue, the employees can continue to service their customers. They also leverage the full text search capabilities so they can get responses to searches, look up information on inventory, etc. in real time. So overall, customer experience, which is again one of the key tenet of edge computing applications, was vastly improved with this solution. And finally, I'll like to wrap up the customer stories with Matrix Medical. This is a mobile healthcare provider. This is a field application in the healthcare space. Here, caregivers, nurses, they visit patient sites in remote areas where there is typically no or very poor network connectivity. But when they visit these patients, they need to have access to the patient health records. They have to be available in an offline mode, and they also have to be able to update, for instance, the medication information or the history or the user profile information, and all this has to be done even if there is no network connectivity. And of course, when there is network connectivity, the data is then synced back to the mothership. So to wrap things up, I want to summarize that the edge computing architecture is a key enabler of mission critical applications where guaranteed high availability, real-time responses, data privacy, and scalability are critical. Now, again, such a distributed compute architecture, it works in concert with a centralized cloud-centric architecture. So the cloud continues to provide the benefits of elastic scalability, long-time data persistence, and global analytics. The Couchbase data platform is very well suited for such distributed cloud deployments as well as cloud-centric deployments. Here are some helpful resources where you can find more information. You can download Couchbase for free and try out all the capabilities. And finally, I just scratched the surface in terms of the Couchbase platform and how it enables edge computing applications. Our flagship free developer conference is virtual this year. It's a 3-day conference. It's scheduled for October 14th through 16th. It's free, so you can hear a lot more about Couchbase and its role in edge computing. So hope you can join us then. With that, thanks for listening and have a good day. Thank you.